everybody. This is part 2 of the U-sub video. You should have watched the U-sub introduction video, which had some examples and the notes for you. If you didn't watch that yet, pause right now, watch the other one, and then come back. So here, I'm just going to get you started on this half sheet that you got in class that has all the equations in, and I'm just going to make sure you're going to highlight this correctly. And then I'm going to get you started on some of the U-tries so that when you come to class, you're set to go and we can move to more problems. So you can't do U-sub if you're not able to successfully pick out what U and the DU parts will be. So for this, I'm going to let U be purple, and I'm going to let DU parts be yellow. So when you look at a problem, remember, U is always going to be the thing with the bigger power, or it could be the more complicated expression, or it could be the exponent, or it could be in parentheses. And you have to remember, if you pick U and then you do the derivative of it, the derivative of U needs to be an expression somewhere. If it's not, then you have to change your U choice. So one of the biggest mistakes is, let's look at number 1 here. Some people look at this and they say, oh, 3x, but they want to make U be cosine of 3x. Well, if I do the derivative of cosine of 3x, that's negative 3 sine of 3x, and there's not a sign in sight here. So I have to just let cosine be because I know what the antiderivative of cosine is. And I'm going to try making U just be 3x. Well, the derivative of 3x is 3. Oh, that's perfect. It's right here. How about the next one? Notice that the 6 U tries are from this half sheet. They are numbers 2, 5, 8, and then 15, 18, and 20. So that's where I got those 6 U tries, just so you know. Let's take a look at this one here. If I let U be 1 plus 5x squared, then the derivative of that is 10x. I don't have exactly 10x, but I can manipulate it to get 13x. Let me do one more here. How about this one here? The thing with the higher power is clearly the x to the 5th, and I do not want to include the square root. Because if I include the square root, then the derivative needs the chain rule, and it's going to have things to the negative half power. That's way crazier than just this x to the 4th. The derivative of my pink U here, or purple U, is 5x to the 4th, which is pretty much what I have here. I can manipulate it a little bit. So continue highlighting here, and when you're done with that, I want you to go to your notebook where you wrote down the 6 U tries, which were at the end of this video here. And I'm going to get you started on just a couple of them. And then hopefully you will feel confident enough to finish them off. So let's take a look at this one, which was number 2 on your half sheet. And we had let U, oh, we didn't do this one, but let's say the thing with the higher power here is the x squared term. And the du part will somehow involve this x. So let's let U be 5 minus x squared. Well, the derivative of U with respect to x is a negative 2x. So now I'm going to bring the dx to the other side. So now I'm looking at this. Well, if I look at my integrand here, I do not have negative 2x dx. I only have x dx. So we're going to force this to say x dx. So let's divide by negative 2. And you can only do this manipulation by multiplying and dividing, never by adding or subtracting anything. So that's gone, and I now have x dx. Check it out. Now it's exactly what I want here. So now let's take our integral, and the whole point of U-sub is to rewrite this so it's in a nicer form, a form that I can do in my head. So let's take, this was U, remember, and then this was our du parts. So I'm going to, instead of U, or 5 minus x squared to the 4th, I'm going to write U to the 4th. X dx is going to be replaced with negative du over 2. Now some people look at this and they're like, oh my god, I don't know how to do the integral of that because there's this over 2 here. What does that mean? Rewrite it so that it looks nicer. This constant, remember properties of integrals, you can pull a constant out. That's just negative 1/2. U to the 4th. Du should always come last. That's how you're used to seeing integrals, and it'll be easier for you. So now I can just do the antiderivative of U to the 4th. That was the whole point of rewriting it. That's easy. U to the 5th over 5. And I have a plus C here. The last thing is just to combine your constants, and then I need to go back to my x talk here. So I replace U with what I originally let U be, which is that. Okay, let's get going on this one here. So I'm going to go ahead and let u be the thing with the higher power. So it looks like u should be that. And then the du parts, well, the derivative of this is 0 plus 10x. So let's go ahead and write that down. 10x. Now, I don't have 10x here. I have 13x dx. So we're going to need to do a little bit of manipulation here. So I have 10x dx. And what I really need is what is in my original integrand, which is 13x dx. Well, I can multiply or divide to fix this here. So let's multiply by 13 over 10. And that'll work out real nicely because that's gone. And then I have 13 over 10 du equals 13x dx. And it'll work perfect because the thing I highlight in yellow here is what I highlight in yellow here. So let's rewrite our integral. So it's a lot simpler now. In the denominator, I'm going to throw my u. 13x dx is the same as 13 over 10 du. That came from right here. So this is my u parts, and this is my u. All right, so let's make this look a little bit nicer. Constant out front, always, always, always. Du over u. Now, some people freeze up here, and they're like, well, I don't know how to do the antiderivative of that. But you do! All you have to do is rewrite it so that it looks like what you're familiar with. Du over u is the same as 1 over u times du, and you definitely know how to do the antiderivative of 1 over something to the first power. So that's 13 over 10 natural log of u plus c. We'll talk about the absolute value bar soon. So 13 over 10 natural log of 1 plus 5x squared plus c. Remember, you always have to go back to your x talk whenever you're doing an indefinite integral, which doesn't have the lower and upper bounds. Now, the next couple I think you'll be okay on. I just want to point out that for this one, to make sure you're going to be okay doing it, u will usually be the thing. If there's an exponent, it should be the exponent. I know that cosine and sine are pretty interchangeable here, but this problem will work out nicer if you let the exponent be u, then you manipulate your du so you end up with what you have. Here's how you rewrite it, and then I want you to keep going. And then for the other ones that I'm not talking about, I'm leaving those out because I think you'll be okay doing them, and go all the way, and we will compare in class Monday and continue practicing. See you later.